Welcome to Alphanumerictricks. Today we are going to see problems under Lagrange's linear equations. Under PDE we are doing problem set of 15. Okay. Now the first problem in Lagrange's linear equations in the previous video. Now we are going to solve y squared p minus xyq is equal to x into z minus 2y and solve x into y minus z into p is equal to p plus y into z minus x into q is equal to z into x minus y. These two problems are very important problem. Either using grouping or method of multipliers, we try to solve the problems. Okay. First problem, solve y squared p minus xyq is equal to x into z minus 2y. Now we have to find out the solution. Given problem is this, and this is of the form, here p is there and q is there and r term is there. So we have p is along with some product of x, y, z, and q is also in terms of x, y, z, r is also in terms of x, y, z. I already told you that instead of this x by z, some constant is also present. Then just p minus q is equal to x. That is also a Lagrange's linear equation. Okay, that is p minus q is equal to x. This is also a Lagrange's linear equation. Okay. Now, this is of the form, so we have to write this. This is of the form Pp plus Qq is equal to R. That is Lagrange's linear equation. Now, we have to write P and Q and R values. P is coefficient of P, that is P is a y squared and Q is capital P. Coefficient of small p is your capital P and is coefficient of small q is your capital Q. That is, you have to write here usually your Pp plus Qq is equal to R. Now here minus is there, so when you taking Q value, you have to take along with the minus sign. Okay, so minus xy and R value is x into z minus 2y. Now we have to form the auxiliary equation or subsidiary equation, both one and the same. So auxiliary equations are dx by p is equal to dy by q is equal to dz by r. Okay, after that you have to substitute p, q and r values. We already know those values, isn't it? So dx by p is y squared is equal to dy by q is minus xy and dz by r is x into z minus 2y. So we have to number these equations as 1, 2, 3. This is called ratios. Okay. Now we have to we try to group the ratios. Suppose when we combining 1 and 2, first and 2, here y get cancelled and equation consists of x, y, dx, dy term alone, isn't it? So grouping is possible. And also it is not necessary that you have to go for both the solutions at grouping. You can go for one as grouping and another one as method of multiplies. That way also you can do it if possible. Okay. Now taking the ratios 1 and 2, we have dx by y squared is equal to minus, you take here minus dy by xy. So here when you taking this y and y, dx by y is equal to minus dy by x. Here dx y x term, dy y term is alone present. So this is possible. Okay, so you can write this to be x dx is equal to minus y dy. Okay, and similarly next one we try to group the second and the third. Okay, second and third, when you taking x get cancelled and dy by y is there and dz by z minus 2y. Anyway y z term alone is present. Y z dy dz alone is present and x's get cancelled when you taking the ratios 2 and 3. Okay, we try to ratios 1 and 3. What happened? Dx by y squared is equal to dz by z into z minus x into z minus 2y, and here x is there. Here nothing is get cancelled. X is not get cancelled here. Okay, sorry, y is not get cancelled here because dx and dz is there. So denominator should have x and z terms only. Okay, x and z terms only. And when you grouping, other terms should get cancelled. Otherwise, grouping is not possible. We have to go for method of multipliers. Okay. So here we have to take all the combinations. Already 1 and 2 is taken. Next we have to take 2 and 3. If 2 and 3 is not gives the answer, this way not coming, so you go for 1 and 3. And if all the combinations are not possible, you have to go for method of multipliers. Okay. Now, we have to take the ratios 2 and 3 because 2 and 3 x is get eliminated, isn't it? So, here dy by minus xy is equal to dz by x into z minus 2y. Here x get cancelled. So, remaining term you have is x is not there and dy dz is there, so only y and z alone is present in our result. Okay, so we have to take this z minus 2y to other side, so z minus 2y into dy is equal to this minus, you take it here, minus y into dz. We have to integrate this and get the two independent solution. Then you combine those solutions, you get the general solution of the Lagrange's linear equation problem. Okay. Now, this is our problem, isn't it? X dx minus, after simplifying, we get this. So, we have to integrate this one. Here, x dx is there, y dy is there. So, we can directly integrate this. Okay. Integrating, you have integral of x dx and integral y dy. X dx is x squared by 2 is equal to this minus you have to retain here, and integration of y dy is y squared by 2 plus a constant of integration c1. After that you have to take this minus y, so that is you have to collect the x and y terms together, that is variables together and constants together. So when you're taking minus y squared by 2 to this side, you have a plus y squared by 2 is equal to this c1. Or you have to take LCM 2 and take that 2 to other side. So you have x squared plus y squared is equal to c1, or you 2 c1 can be taken as another constant a. Okay. So this is our one solution. Now we try to find out the next solution using this another one. So from this is that you have to take this minus. Here we can't directly integrate this because y dy alone is present. We can integrate directly integrate it. But here z into dy is there. Z dy we can't integrate, isn't it? Z dy we can't integrate directly. Z dy integration is not at all possible directly. We will check it out. Okay. So we have to take this. You have to simplify this. You have to take this minus y dy to other side. It becomes a plus y dz. Okay, and when you having this here, after that you have to multiply this term z into dy. Here you have to take this plus y dz to this side and minus 2y dy here. Okay, so when you're expanding this, you get like this z dy minus 2y dy plus y dz is equal to 0, isn't it? From this, we take these two terms, z dy plus y dz minus 2y dy is equal to 0. Okay, so whenever you have this type of problem, x dy plus y dx, x dy plus y dx can be written as differentiation of xy. Why it happens? You have to take this x is you have to apply UV rule here, isn't it? So when you're taking u is constant, so first term is constant, right? It here x into differentiation of second term dy plus y is a second term into first term differentiation, so y into dx. That's why x dy plus y dx can be written as d of xy. In the same way here, z dy plus y dz. How will you write this? D of y z. Isn't it very simple? Minus 2y dy is equal to 0. So this is now it is integration is possible because the y dy is there and differentiation of some term is there. So when you integrating, differentiation integration get cancelled. Now we integrate this one. So integrating this, you have these two terms, integration, differentiation get cancelled. Y z alone is present here, minus 2 into integration of y dy is y squared by 2 plus is equal to some constant of integration, and here this 2 get cancelled. So y is it minus y squared is equal to c2, and this is your, we can take this to be some constant b. Y is it minus y squared is equal to B. Okay, so we get two independent solutions. U is equal to A and V is equal to B. There is no relationship between these two solutions. That you have to check it out. Okay, most of the problems like that only. Some anyway you have to check it out. Okay, and so some problem is there. I'll do it later. Here there is a relation between these two terms is there. That type of problems also there. I'll do it later. Okay, so here now we have to conclude our result. So general solution is phi of u comma v is equal to 0. What is u? X squared plus y squared. What is v? Y z minus y squared. That you have to substitute here. Phi of x squared plus y squared comma v is y z minus y squared is equal to 0. So this is our solution of the given problem. Okay. Now we pass on to the next problem. Solve x into y minus z into p plus y into z minus x into q is equal to z into x minus y. Here p is multiplied with some functions of x, y, z, and q is also a function of x, y, z, and r term is separately there. R is your x, y, z term alone, which is independent from p and q. Okay. So we write the solution. This is of the form Pp plus Qq is equal to R. Okay, after that we have to write capital P and capital Q and capital R values. What is capital P? This one. Small coefficient of small p is your capital P. Okay, you have to write it x into y minus z. And what about capital Q? Coefficient of small q. So capital Q is equal to y into z minus x. And what is R? That is your right hand side term is your R. R is equal to Z into X minus Y. Now you have to find out the subsidiary equations are the auxiliary equations. Both one and the same. So subsidiary equations are dx by p is equal to dy by q is equal to dz by r. Okay, now we have to take this dx by substitute the values of p, q, r here. X into y minus z is equal to dy by q is y into z minus x is equal to dz by r value is z into x minus y. Here a number this as 1, 2 and 3. Is it grouping is possible? Check it out. Suppose when you're taking 1 and 2. Okay, here dx by x into y minus z is equal to dy by y into z minus x. As grouping is possible, here xy is there, xz, yz and yx. Okay, so here z is present here. Xy alone after this z is present, it does not get cancelled. Okay, it does not get cancelled when you're grouping xy minus xz, yz minus yx. Here when you're taking this, here yz is there, here xz is there. So it does not get cancelled. Instead of this one, here you have yz is there. When you adding this, you can these two terms get cancelled. So you can go the different way. Okay. So here it is not possible. So this term z is not get cancelled. So grouping is not possible. Similarly for these two terms, here also y dy dz is there, x is not get cancelled, so grouping is not possible. In the same way, dx dz, here x y dx dz term contains only x and z terms. Y is present here and it is not get cancelled, so grouping is not possible. So only possibility is we have to go for method of multipliers. Okay, so what is the concept of method of multipliers? When you're using multipliers, that when you after using multipliers, when you adding this ratios, when you adding the terms, that should denominator should be equal to 0. When you adding all the terms, okay, when you adding all the terms, you should get the denominator, that value to be 0. According to that, you have to use the multipliers, or this denominator should be integrable. That is the way you have to use the multipliers. So you remember easily, when you are using, after using multipliers, when you are adding all the ratios, the denominator should be 0. That is the idea of using method of multipliers. Okay, so we use the multiplier 1, 1, 1. Okay, we use the multiplier because xy is there. Here we check here xy. Here xy is there. Here xy minus xy is there. And xz minus xz. Here you have my a plus xz. Okay, and and here y is it, here also y is it is there. So you can go for method of multiplies using multipliers 1 1 1. Each ratio you have to, this word you should write, each ratio is equal to, because we're equating this to some ratio, so each ratio is equal to, here we are using this, after using multipliers you have to add it, 1 into dx plus, you have to write like this, 1 into dx plus 1 into dy plus 1 into dz divided by, you have to add all the terms, x into y minus z plus y into z minus x plus z into x minus y. Okay, this is the way you have to use the check the multipliers. If after using this multiplier your denominator has not become 0, so you try to another way, either use minus 1 or minus 2 like that, or it may be even variables also, x y z also you can use for multipliers. Okay, so that is only thing is your denominator should be 0 after using multipliers. When you adding all the terms, your denominator should be 0. According to that you have to use the multipliers, and after you have to write each ratio is equal to. Okay, so dx plus dy, when you adding this you get, take x inside, xy minus xz plus yz minus yx plus zx minus zy. So here these terms get cancelled, isn't it? Here xy is get cancelled, and here xy is xy, and sorry, here xy and minus yx get cancelled, minus xz plus xz get cancelled, and yz minus yz get cancelled. So all the terms get cancelled, so the denominator becomes 0 now. Okay, so you have each ratio is equal to dx plus dy plus dz by 0. Now you can easily integrate it, that is this value. When you're taking whatever the term may be, each ratio is there, here some ratios are there, our ratios 1 2 3 ratios is equated to this thing. Okay, so when you're taking any of this, that because of this 0 it becomes 0, so dx plus dy plus dz is equal to 0. Now you can easily integrate it, integrating integral of dx is x plus integral dy is y plus integral dz is z plus a constant of integration a. Okay, now there is no simplification, that's why we directly use the constant a. Okay, now where this is our one solution. Now we pass on to the next solution. So I already told you that grouping is not at all possible for this problem. So next we have to use the another multipliers. That is, our problem is this one, isn't it? What is our problem? Our problem is that is our dx dy is x into y minus z is dy into, this is our problem, dy into y minus zx plus dz into z minus x minus y, isn't it? So we had to this one, we have this. Okay, so this is our problem, dx by x into y minus z is equal to dy by y into z minus x is equal to dz by z into x minus y. This is our ratios we have, isn't it? So how we can use this multiplier 1 by x, 1 by y, 1 by z? Here look at this one. If the terms is not present here, if your x, y, z is not present here, then what is your term left out? Y minus z, z minus x, x minus y. This alone is left out here, isn't it? So this is not present in your, assume that this is not present in your ratios. Okay, so when you adding these terms here, minus zx plus z plus y minus y plus x minus x get cancelled, you get 0. So how will you eliminate this x and this y and this z? That's why we are using multipliers 1 by x, 1 by y, 1 by z. That is, when you're multiplying this with 1 by x, these two terms get cancelled. When you're multiplying this with 1 by y, these two terms get cancelled. When you're multiplying 1 by z, these two terms get cancelled. When you are doing this alone in the denominator, your solution is wrong, isn't it? So whenever you are doing, you have to, suppose if it is in division, you have to do these things in both the numerator as well as in the denominator. Okay, that is the idea of using multiplier. So we use this, each ratio is equal to 1 by x into dx plus 1 by y into dy plus 1 by z into dz is after this step. Okay, we are using this now. So here when you are taking 1 by x, 1 by y, 1 by z for each the ratios, and we are adding all the terms. Okay, so for your understanding only I write this step. Okay, this step for your understanding only I write it. In your exam you directly write each ratio is equal to 1 by x dx plus 1 by y dy plus 1 by z dz. We are adding all the numerators separately divided by the denominator separately. 1 by x into x y minus z plus 1 by y into y z minus x plus 1 by z into z x minus y. Okay, so here your x get cancelled and y get cancelled and z get cancelled, isn't it? After that you have this term dx by x plus dy by y plus dz by z divided by this term y minus z plus z minus x plus x minus y alone is present. So here the terms are get cancelled. Minus y is get cancelled with plus y, minus z plus z, minus x plus x get cancelled. All the terms get cancelled. So the denominator becomes 0. Dx by x plus dy by y plus dz by z divided by this 0 you have. That is, here you have some ratios, isn't it? When you're taking this 0 to any number, it becomes 0. So directly you get dx by x plus dy by y plus dz by z is equal to 0. You have to integrate this. Okay, what is integral dx by x? You know that it is very easy, log x, isn't it? So log x plus log y plus log z is equal to constant. Here we have to use any constant, but here log is there, so you have to use this constant also, log, for our simplification purpose. How will you write log x y z? Log a plus log b plus log c, isn't it? Log a b c. Okay, log AB is equal to log A plus log B. So this formula is applied here. So log X plus log Y plus log Z can be written as log of XYZ is equal to log A, or your log A and your log get cancelled. So XYZ is equal to, we use the same constant. We already one constant used in our A. So we use it to be B. So this is our next solution. So the general solution of the given problem is phi of u comma v is equal to 0. What is u? U is x plus y plus z and v is x, y, z. And one thing you should remember, if you are using different multipliers, sometimes this result may vary for person to person. That also you should remember. That is, the solution is not unique here. Suppose you are using some other multipliers, there may be a chance of varying this result also. Okay, thanks for your time and thanks for watching. If you want some other problems I want to do it, please comment in the comment section. Thanks for your time and thanks for watching. Thank you.